For more than half a century, the Pioneer, the Voyagers, and more recently, New Horizon, have ventured into the far reaches of the solar system, undertaking a voyage so vast in space and time, it stretches the limit of our understanding of the universe's staggering scale. My fascination for science was sparked in 1989 as an 11-year-old boy reading about Voyager 2 reaching Neptune. This channel's name was inspired by this singular event. It's not easy to visualize and comprehend the true size of our solar system, let alone the universe. Saying that space is huge is a massive understatement. If the sun was this softball, Earth would be this pinhead sitting 32 meters away. The moon, not visible at that scale, is here, over 8 centimeters away from Earth, and this is the extent of human space travel so far. Jupiter would be this 3-centimeter sphere, about 168 meters from the Sun. Slightly smaller, Saturn is laying 370 meters from the softball. More than double this distance at 640 meters, we get to Uranus here. This 1-centimeter green marble represents the 8th planet. Neptune is further from Uranus than Saturn is from the Sun. Traveling an additional 331 meters, this blue marble is slowly cruising 971 meters from the starting point. On that scale, light covers about 240 meters per hour, about the distance between these high-voltage pylons. It takes 4 hours to reach Neptune here. Pluto would barely be visible, measuring 300 micron and oscillating on an orbit between here, inside Neptune's orbit, and here, 1,750 meters away. Visualizing the solar system alone can be helpful in that way. But even at that scale, the distance to a nearby star or the center of a galaxy requires an additional stretch of imagination. If this softball sun was in Detroit, Michigan, the closest star, Proxima Centauri, would be in Santiago, Chile. Light would get there traveling about 6 centimeters per second in about 4 years. On that same scale, the galactic center would be where Mars makes its closest approach to the Earth, 54 million kilometers away. For now, let's stay in the solar system and the probes we send out to explore it. Jupiter and Saturn were visited multiple times by various space missions, but only one spacecraft visited and photographed all 4 gas giants in the outer solar system. Using that softball sun analogy again, Voyager 2 is currently over 4.5 kilometers away. Its twin sister space traveler Voyager 1 is now 5.4 kilometers away, 900 meters ahead of Voyager 2, or about the same distance separating Neptune from the Sun. Only Voyager 2 is on a different plane, aiming in a completely different direction. Voyager 1 is traveling in the general direction between Hercules and Ophiuchus, visible in the summer from the northern hemisphere, not far from the general traveling direction of Pioneer 11. Voyager 2 can be detected in the Peacock constellation, only visible from the southern hemisphere. From our moving vantage point, these space travelers are far closer from us than the star background, and their position shifts and wobbles over the course of a year. Although launched a full 5 years ahead of the Voyagers, Pioneers are lagging behind due to a slower velocity at launch and less aggressive gravity boost at Jupiter and Saturn. Pioneer 10 and 11 were receiving data on 2.11 GHz and responded on 2.292 GHz. With a radio beam about 3 degrees wide, its antenna must be carefully aimed at the Earth for successful detection and transmission. Unlike the Voyagers, the Pioneers are constantly spinning on their axis at 4.8 revolutions per minute to maintain stability. Unless a collision occurs since the last signal, they are both still rotating, as they have for almost 60 years. Pioneer 10 hold many firsts. First to venture past the asteroid belt, first to visit and study Jupiter up close in 1973. Pioneer 10 was the first man-made object to cross the orbit of Neptune and leave the solar system in 1983. 14 years later, in 1997, when it was over twice the distance to Neptune, it was still in operation. Pioneer 10 faint transmission was used to train radio astronomer in weak signal detection. Written by Carl Sagan in 1985, the sci-fi novel Contact, adapted for a movie released in 1997, used chaos theory and noise pattern recognition based on Pioneer 10 signal detection. Pioneer 10 continued to transmit data. It was detectable until early 2003, when the signal was lost. Several more attempts to contact the probe were made until 2006, but remained unsuccessful. Now over 142 astronomical units away, or 4.5 kilometers in the analogy, it is still drifting silently between the Kuiper Belt and the Oort cloud. It should reach the entrance of the Oort cloud in about 10,000 years. If no collision, in roughly 2 million years, Pioneer 10 will visit the Aldebaran system, the main star in the constellation of Taurus, visible from the northern hemisphere in the fall or winter. Long before that, it will pass near this star in Cassiopeia, about 83 light years away now, but much closer when Pioneer 10 reaches it in about 90,000 years. Pioneer 11 visited Jupiter as well late 1974. It was the first spacecraft to fly over the pole of Jupiter, capturing never-before-seen images of the giant planet and its turbulent atmosphere in that region. Pioneer 11 was also the first gravity assist to slingshot to Saturn. Early September 1979, Voyager 1 had already passed Jupiter and was on its way to Saturn. Not knowing if the ring of Saturn would damage the spacecraft, Pioneer 11 survived and cleared the way for the Voyagers later, capturing the first image of Titan, Dione, Mimas, Janus, Tethys, Enceladus, Calypso, and Rhea. In 1990, Pioneer 11 passed the orbit of Pluto. It continued to transmit useful data until late November 1995, when contact was lost to low nuclear battery power. Pioneer 11 is now somewhere 118 astronomical units away, or 3.7 kilometers away here. Pioneer 11 is in the general direction of the Eagle, a northern hemisphere summer constellation a few degrees south of Voyager 1's current position. Given the motion of nearby star, in 928,000 years, Pioneer 11 will get within 0.8 light years of TYC 1921 in the constellation of Ophiuchus. Out of all the interstellar travelers, Pioneer 11 will make the closest approach to any star in the near future before reaching the double Lambda Aquila system in 4 million years. Pioneer 10 is slightly faster than Pioneer 11, but both are traveling at 11 kilometers per second in a region of the solar system 4 to 5 times further away than Neptune, between the Kuiper Belt and the Oort cloud. With power level below the transmission threshold, neither probe have the power to communicate with Earth, and with no trajectory correction for over 2 decades, it's likely they are not pointing at the Earth and contact is probably lost forever. As a side note, one of the Pioneer is depicted on this artwork in the US passport since 2007. Contact was lost with the Pioneers sooner than the 5 years separating them from the Voyager's launch, mostly for 3 reasons. For one, the nuclear battery on board Pioneer 10 and 11 generated 155 watts at launch, significantly less power than the 470 watts of the Voyagers. 2, the Pioneer had an 8-watt transmitter versus the 23 watt on the Voyagers. And 3, Pioneer broadcasts on a lower frequency. Given the same dish antenna, a higher frequency can keep a more focused beam than the lower frequency. The strength of the received signals depends on it. 3 arc degrees for the Pioneers and 1 arc degrees with the Voyagers. The Voyagers 1 and 2 are receiving data from Earth on 2.1133 GHz and 2.1146 GHz respectively, with 100 kHz bandwidth, transmitting 24/7, 365 days a year, with the occasional data packet broadcast on 8.42 GHz for Voyager 1 and 8.415 GHz for Voyager 2. Comparing the Voyager transmission power to a fridge light bulb is a bit misleading. 23 watt at 8 GHz is more than twice the power most radio amateur can generate on 23 centimeters or 1.2 GHz. The vast majority of radio amateur do not transmit a carrier at that power level on that frequency for half a century continuously. This deserves some respect and recognition. Voyager 1 holds many records, and first, as it was leaving our planet, Voyager 1 took this picture of the Earth and the Moon right after launch in September 1977. This was the very first time our planetary system was photographed from this angle. The Voyager 1 team is credited for the discovery of active volcano on Io in 1979. Every nerd, including myself, had this poster of the Saturn system taken by Voyager 1 in November 1980. After its encounter with Saturn, Voyager 1 crossed the orbit of Neptune in 1990 when it took this famous pale blue dot picture championed by Carl Sagan. This was the last picture received from Voyager 1. As of February 1998, when it was over twice the distance to Neptune, Voyager 1 became the fastest and the furthest man-made object, outpacing Pioneer 10. On an escape angle of 35 degrees from the solar system ecliptic, Voyager 1 is now heading for a main sequence AIM type star AC plus 79 3888, also named Galaxy 445, located about halfway between the Little Dipper and the Big Dipper. It will get within 1.6 light years from it in about 40,000 years. Voyager 2 holds a special place in space exploration. No other spacecraft has ever visited, photographed, explored, and investigated more planets and discovered more satellite than Voyager 2. The study of Jupiter by the Galileo and Juno mission were an extension of the Voyager program, itself supported by the Pioneer 10 and 11 previous visit. The Cassini-Huygens program to explore Saturn and its many moons was designed following Voyager 2 and Pioneer 11 findings. The overwhelming majority of what we know about Uranus and its satellite, Neptune and Triton, is a legacy of Voyager 2 and Voyager 2 alone. To this day, no other space mission has ever visited these two distant ice giants. In April 1979, Voyager 2 was the fourth probe to visit Jupiter. Because of Voyager 1 previous pictures, it was possible to redirect the focus on the volcano of Io and the icy moon Europa. Flying much closer, Voyager 2 transmitted 17,000 new pictures of the Jovian system. The combined data from both Voyagers allowed planetary scientists to map out at least 80% of the surface of Ganymede and Callisto to a resolution of about 3 miles. In August 1981, Voyager 2 arrived at Saturn. Following in the footsteps of Pioneer 11 and Voyager 1, Voyager 2 flew through the outer rings at 13 km per second. The increase of particles and dust forced the spacecraft to readjust its position many times for several minutes. Voyager 2 photographed the moon Hyperon and Enceladus, later investigated by Cassini for possible geological activity. Also, new photographs of Tethys, Phoebe, Telesto, and Calypso were made, and pictures of the recently discovered Helen. During its 1981 flyby of Saturn, Voyager 2 discovered 3 new moons named Atlas, Prometheus, and Pandora. The last 2 are ring shepherd moons. 4.5 years later, Voyager 2 arrived at Uranus, early 1986. By then, the gravitational slingshot from Saturn had propelled the probe to 17 km per second, which only gave it a 5-hour flyby of what was then the 7th planet. Voyager 2 discovered no less than 10 new moons and returned spectacular photos of the 5 largest moons: Miranda, Oberon, Ariel, Umbriel, and Titania. Although mostly featureless, Voyager 2 was able to measure wind speed in Uranus's atmosphere over 724 km per hour and a possible ocean of water some 800 km below the cloud tops. Voyager 2 also recorded radiation level off the chart at Uranus, likely due to a solar flare happening in late 1985, reaching Voyager 2 and Uranus early 1986, and amplified by the planet's magnetic field. Late August 1989, Voyager 2 observations provided humanity first and only up-close look at Neptune. The fastest wind in the solar system were recorded there, exceeding 2,000 km per hour. 4 new rings and 6 previously undiscovered moons were found orbiting Neptune. Voyager 2 also revealed active liquid nitrogen cryovolcano on its largest moon, Triton. But in order to get to Triton, the JPL team had to fly Voyager 2 very close to Neptune's North Pole, less than 8,000 kilometers above the upper clouds of Neptune. This was a risky maneuver, but confirmed the high wind previously mentioned. Hydrogen was found to be the most common atmospheric element along with methane, which gives the planet its blue appearance. Voyager 2 is the only spacecraft to have fully accomplished the original ground tour envisioned by JPL summer student Gary Flandreau in 1964. Shortly after its encounter with Neptune, Voyager 2 was put on low-power conservation mode for what is now an interstellar mission. On July 14, 2000, a massive solar flare erupted and was detected by Voyager 2 as a shock wave 6 months later, confirming the spacecraft was healthy and at the expected position and distance. Voyager 2 crossed the heliosphere in 2007, where the sun's influence started to dwindle. Voyager 2 is traveling 48 degrees south of the solar system plan and is aiming towards the general direction of the star Ross 248 in the constellation of Andromeda. It should pass within 1.7 light years in 20,000 years before continuing towards the brighter star Sirius, passing within 8 light years in 300,000 years. Both Voyager spacecraft are equipped with position correction thrusters fed from hydrogen tank. There is plenty of hydrogen left, but the thruster's exhaust can get clogged from debris and iced over hydrazine. As a testament of 1970s technology, 42 years after launch, on July 8, 2019, Voyager 2 successfully fired up its trajectory correction maneuvers thrusters. They were last used 30 years ago during its encounter with Neptune in 1989. Both Voyagers have seen their power reduce and instrumentation shut down one after the other, although the power loss is mostly due to thermocouple degradation and not a direct result of the plutonium-238 decay. As of 2026, both Voyager probes are still active and transmitting. After almost 50 years of continuous operation, it should be obvious the Voyagers are living on borrowed time. Sooner or later, the power will fail. Sometimes in the 2030s, the power is expected to fall below the 60-watt threshold needed for transmission, leaving behind a time capsule from the 70s. In about 300 years, the Voyagers will enter the Oort cloud. Collision with anything there is unlikely given the low density of small bodies in that region. You'll have better odds shooting at the sky and hitting a penny-sized target between the Earth and the Moon than the Voyagers or the Pioneer hitting anything in the Oort cloud. New Horizon is the latest controlled object to leave the solar system. It is currently about 64 astronomical units away, or 2 kilometers here. Launched 34 years after Pioneer 10 and 29 years after the Voyagers, it will take New Horizon over 100 years to pass Pioneer 11 and about 300 years to catch up with Pioneer 10. Because the sun's gravitational attraction is slowing all of them down, New Horizon will never catch up to the Voyagers, traveling at 17 km per second for Voyager 1 and 15 km per second for Voyager 2. The Deep Space Network communicates with New Horizon on 7.2 GHz and it sends data back to us on 8.4 GHz. Even with only 12-watt power output, the X-band allows for more data to be transmitted. Launched 20 years ago, New Horizon flew by Jupiter for a gravity assist boost to Pluto, shortening the trip by 3 years. At Jupiter, it observed more eruption on Io, first seen by Voyager 1 28 years prior. It studied the violent atmosphere of Jupiter and the magnetic environment of the giant planet discovered by Pioneer 10 34 years before that. New Horizon crossed the orbit of Neptune exactly 25 years to the day after Voyager 2's encounters with the same planet. New Horizon arrived at Pluto in mid-July 2015, providing never-before-seen image of this distant world. For weight consideration, New Horizon does not have an instrument platform able to rotate like the Voyagers. Instead, the whole probe must align itself to the target, make its measurement, and take the picture, return to a position facing the Earth, For its antenna to transmit the recorded data, at the distance of Pluto, radio signals take 4.5 hours to reach Earth, and the data transfer took over 15 months to complete. During its very fast and successful encounter with Pluto, New Horizons captured some stunning pictures of this distant tiny world and raised more questions about the dynamic of the solar system, its formation, and the resemblance with Triton. 4 years later, New Horizons passed within 3,500 kilometers of a small Kuiper Belt object originally named Ultima Thule and renamed Arrokoth. Arrokoth is the first KBO and the furthest object ever visited by a spacecraft. The encounter happened on New Year's Day 2019 and only lasted a few minutes, as seen here in real time. Arrokoth and New Horizons were then 42 astronomical units away, or about here. The spacecraft is still fully operational, probably until the late 2030s. For now, New Horizons has technically exited the Kuiper Belt. Much like the Voyagers before, its mission has shifted to the study of the heliosphere. From our vantage point, New Horizons is in the constellation of Sagittarius. Unlike the Pioneer and Voyagers before, New Horizons does not carry any golden record or plaque. Instead, it took a few mementos and personal items to eternity. Most notably, a few grams of ashes of late Clyde Tombaugh. New Horizons is not heading in the direction of any particular star. It could still be redirected to a new suitable target if one is found to be of interest. Just like the other interstellar space probe before New Horizons, it too will navigate the void long after Vega become the new northern star and beyond the time when South Africa collides with North America. No spacecraft has ever suffered any damage during the asteroid belt transit, but no one knew that for sure when Pioneer 10 was launched in 1972. The Pioneer probe were true pioneers in that sense. Between 2 and 3 astronomical units away from the Sun, the asteroid belt is actually very much empty. The millions of small-sized objects ranging from dust particles to dwarf planets are separated by an average of 1 million kilometers. The Kuiper Belt is a bit more crowded, but even there, space is so vast. These 5 robots are unlikely to hit anything during their transit. The Oort cloud is even less dense. The Jupiter radiation belt was another unknown the Pioneer explored for the first time. 50 to 100 rem is usually lethal to human. The Pioneer were designed to sustain 20,000 rem, but Pioneer 10 received between 200 and 250,000 rem in Jupiter's vicinity and continued working. Juno and Galileo were radiation hardened thanks to what we learned from the Pioneer's visit. Both Pioneers and Voyagers' contributions to the scientific advancement and understanding of the solar system cannot be overstated. The unique vantage point the spacecraft offers provides an invaluable source of data for future missions. Planetary scientists are still going through the Voyager's record to this day. During this ongoing science exploration of the outer solar system, the study of the interstellar medium and the sun's influence is still generating new discovery. As of 2026, much efforts are underway to keep the Voyagers transmitting for as long as possible, maybe into the 2030s. Ultimately, even with enough power, the Voyager's signal will fade into noise. Just like the Pioneers, it would eventually be too weak and distant to be detected. The plutonium in the RTG still has about 68% of its original 200,000 Curie activity. It could provide enough power for a few more decades. However, the thermoelectric interface degrades over time and loses efficiency. The power steadily decreases until a low voltage threshold is reached. The undervoltage fault protection system may trip and the transmitter will fail. Someday, contact will be lost. For now, very large antennas using detectors cooled with liquid helium can barely detect a signal from 24 light hours away. With fading powers and ever-increasing distance, the Voyager signal will eventually become part of the background noise, and the information they carry will be lost. After 50 years of continuous service, the ultimate end of the Voyager's mission means the longer space science experiment and exploration will fade away. Set by engineers in the late 60s, the Pioneers and the Voyager program will be remembered by fewer and fewer people. The console used to communicate with the Pioneer has already been dismantled and scrapped. Although more recent, the New Horizon is not immune to this fate either. The Voyagers and the Pioneers are now fulfilling their last mission. The golden record on the Voyagers and the infamous plaque on the Pioneers are now the hopeless interstellar ambassador for humanity, roaming the galaxy for eons. At the time of the first stellar encounter, the plutonium power supply will have completely decayed to uranium-234. Because uranium-234 has a half-life of 245,000 years, no radioactive circular equilibrium can be reached, no renewed power burst. After uranium-234, the decay chain continues to thorium-230, where it merges with the natural uranium-238 decay chains we are familiar with, radium-226, radon-222, polonium-218, and so on, getting weaker and weaker. In about 3 million years, the inside of the RTG might just be mostly made of stable lead oxide. It's difficult to predict exactly where gravity will eventually take these probes in a far distant future, but as long as they remain undisturbed, they will all continue on the same trajectory they have been for decades. Traveling much slower than the escape velocity of the galaxy, Pioneer 10 and Voyager 1 would orbit the Milky Way and return to the Sun's vicinity in about 4 billion years, oscillating in and out of the galactic plane every few 100 million years. Voyager 2 is on a similar orbit, but it will be halfway from the Sun's position in about 6.5 billion years. By then, Andromeda will have collided with the Milky Way, and Voyager 2 could be slingshot in intergalactic space. Pioneer 11 is on a shorter orbit, a bit closer to the center of the galaxy, and will be coming back around in 4 or 5 billion years. New Horizon can still change its trajectory, but will probably follow a similar path. They could also be captured and perhaps orbit a distant star, maybe crash on the moon or a planet, but this has a 50-50 chance of happening in the next 10 to the power of 20 years. The vacuum of space will preserve them for billions of years. Energetic particles from cosmic radiations and micrometeorites are the only threat to the probe's integrity. This means the Pioneer, the Voyagers, New Horizon, and a few rocket boosters in third stage tumbling through space, leaving the solar system, will likely outlast the oldest monuments and man-made artifact on Earth. Before planned obsolescence, back when we built things to last generations, these machines are taking a message to eternity. Once upon a time, we existed.